Okay, I'm going to review some homework questions in pre-calculus on 5.2. The assignment was 1 to 41 odds. Here are some of the ones that were asked by the students. Now I notice that this is cosine, cosine. So what are all my rules? Let me start with them real fast. Cosine alpha plus beta. When it's cosine, it always starts cosine, cosine. Does this start with cosine, cosine? So that tells me it's a cosine. And then it's the opposite sign, so it's minus sine A, sine B. You also have cosine of A minus B, which again is cosine, cosine, opposite, and then sine, sine. Now how about the signs? Sine of alpha minus, let's do plus. Do you know what this is? Sine A, cosine B, the same sign, and then reverse it. So it would be cosine of A, sine of B, except I think they write it sine, this is a plus, they write it as cosine A, sine B, cosine A, sine B. I just remember that they're the opposites. And again, if it's a minus, sine keeps the same sign. So sine A, cosine B, so it'd be minus cosine A, sine B. Does this seem to match one of these? There's ones for tangents also, but these are the sine and cosines. Which one does this match? It's a cosine with a plus. So would it be this one? So what is this going to equal? I believe that this is going to equal cosine of A minus B, isn't it? So what's A? 5 pi over 12. And minus B, what is B? Pi over 12. 5 twelfths minus 1 twelfth is 4 twelfths. 4 twelfths simplifies to 1/3, or pi over 3. What is the cosine of pi over 3? And that's how we got number 7. That was number 7. We had to use that circled identity. Now, number 9, cosine A minus B. Does that look like the same identity? I think it is the same identity. So, I'm going to call this what it says, cosine A, cosine B, opposite, so it'd be sine A, sine B. What are they both divided by? Cosine A, sine B, right? And what are they divided by? Cosine A, sine B. Does anything divide out of these? Cosine over sine is cotangent, and it's a B. Sine over cosine is tangent, and it's of A. Addition is commutative, so cotangent plus tangent is the same as tangent plus cotangent. And it matches what we were supposed to show. Okay, number 11, I think, matches cosine of A minus B. That identity is cosine A, cosine B, the opposite, so it's plus sine A, sine B. So what I'm going to do is fill in what A and B actually are. So what is A? So where I see the A, I put X's. Any questions? B is pi over 4. So where I see B's, I put pi over 4's. So you get cosine of X times, I believe, the cosine of pi over 4 is the same as the sine of pi over 4. They're both radical 2 over 2. If you factor the radical 2 over 2 out, what remains is cosine of X plus sine of X, which hopefully matches what we need it to match. Okay, in addition to 11, I think I was also asked numbers 15 and 17. 15, I'm going to break it apart into two numbers that add to 105 degrees or subtract to 105 degrees, but I need reference angles that are within the trig values. 60 and 45, is that okay to use those? Okay, so this is now in the form of sine A plus B, correct? So what does the sine do? It's sine A cosine B, same sign, then the opposite. Cosine A, sine B. Does that sound right? Okay, so let's fill this in. Sine, cosine, cosine, sine. What goes in place of every A? 60 degrees. What goes in place of every B? 45 degrees. 45 degrees is pi over 4, and sine and cosine of 45 degrees are both radical 2 over 2. Now it happens that the cosine of 60 is 1/2, and the sine of 60 is radical 3 over 2. Top times top, bottom times bottom, top times top, bottom times bottom. Write it as a single fraction, and I'm hoping this is the answer for number 15. Hopefully everybody's making a note card with all these identities. I most likely will let you use them on some of the upcoming quizzes. Now here is an identity for cosine of A plus B on 17. We just need to fill in what A and B actually are. So A happens to be 135 degrees. 135 degrees. B is 30 degrees. Now I don't really want to modify it too much, because if I was to look at a unit circle and I went to 135 degrees, here is 135 degrees. Its reference angle is 45 degrees, which is on the trig table. So I don't think I want to adjust it. What's the cosine of the reference angle? Would it be radical 2 over 2? However, in this quadrant, negative, positive, cosine, sine, so the cosine should be negative. This one should have a negative on it. Any questions on why this one here is a negative? Okay, the cosine of 30 degrees. Does anybody know? Good. And the sine of 30 degrees. 1/2. So this gives me top times top, bottom times bottom. What would I have? Negative radical 6 over 4 minus radical 2 over 4. So I don't know how you want to do this. Negative radical 6 minus radical 2 all over 4. That's probably the way the book's going to write it. In the textbook, they take the negative out. So if you take the negative out front of the fraction bar, you'd have radical 6 plus radical 2 all over 4. This is the actual answer the textbook has, but they are equivalent. Okay, after 17, next one I was asked was 21. 21 is a tangent. So is there a rule for tangent of A plus B? Please tell me if I have this wrong. I believe it's tangent A, same sign, tangent B, and on bottom, one opposite sign, tangent A times tangent B. To me, that's the formula. I may be wrong, but I don't believe I am. So we will fill in what A and B are, and then we will figure out what this is. Hopefully the overall value of this. So what is A? Pi over 6. So I put pi over 6 wherever I saw an A. What is B? Pi over 4. And now I have it, I just need to fill in values. Can anybody tell me from your trig table the tangent of pi over 6? Radical 3 over 3 is what I always thought it was. Plus tangent of pi over 4. 1. 1 minus What's the tangent of pi over 6 again? Radical 3 over 2 times the tangent of pi over 4, which is 1. So what does this become? Radical 3 over 3 plus 1, all divided by 1 minus radical 3 over, this should be over 3, shouldn't it? Now, what's the opposite of, I will never accept a fraction within a fraction, so you have to learn how to deal with those. What's the opposite of dividing by 3? Multiplying by 3, but that would change the value, so I'm going to multiply by a fancy form of 1 so that I don't change the value. When I distribute here, what happens? Will the 3's cancel? Leaving me radical 3, right? When I multiply here, what's 3 times 1? 3. Over 3 times 1, 3. Minus, and when you multiply here, the 3's would cancel, leaving you radical 3. Looking at the answer in the textbook, I would suggest you leave it like this. The answer in the textbook is wrong, I believe, because they have a 1. And I double-checked it in my last period. I'm pretty sure I just did it right again. Now, I don't know. I can tell you in the past, we've never allowed students to leave radicals in the denominator. So to get rid of this radical in the denominator, I'm going to multiply by its conjugate, 3 plus radical 3. On top, you get 3 plus radical 3 quantity squared. 3, let me go back to white. You'd get 3 plus radical 3, and that would be squared. On bottom, do you know what a minus b times a plus b is going to yield? A squared minus b squared. So if this is a, what's a squared? If this is b, what's b squared? So you end up with a 6 on the bottom. When you square this out, you square the first, twice the product, and you square the last. 9 plus 3 is 12. These are both divided by 6. So the answer I would prefer is this. But the book leaves it like this, and I always say match the answer to the back of the book. They leave a radical in the denominator, so I guess in this one it's okay. Okay, after 21, somebody asked me 29. I like these type, fair warning. Which one does this match? Does it go cosine, cosine, or does it go sine, cosine? So is there something that says sine A cosine B minus cosine A sine B? Yes, and it's a sine one. Is it the same or opposite? I believe it's the same. I think cosine has the opposite ones. So I believe it to be sine of A minus B. So let's fill it in. What's A? 5/12. What's B? 1/4 pi. So now I have 5/12. You need a common denominator. Would 1/4 be 3/12? What's 5/12 minus 3/12? 2/12, which simplifies to pi over 6, or 1/6 pi, and the sign of that is 1/2. Okay, after 29, I was given 31. Is there an identity that says tangent of A minus tangent of B all over 1 plus tangent of A tangent of B? This would be tangent of A minus B, right? Do you agree this would be tangent of A minus B? I believe. I always remember the tangent, it's the same sign on top. So let's fill in. What's A? Pi over 5. What's B? Pi over 30. What is 6/30, which is 1/5, minus 1/30? 5/30, which 5/30 simplifies to 1/6 pi, or pi over 6. And what is the tangent of pi over 6? Okay, after 31, I was asked 37. Okay, do we know a rule for tangent of A minus B? What is it? Tangent A, same sign, so it's minus tangent B, over 1, the opposite, so this would be tangent A times tangent B. So we'll fill this in. Tangent minus tangent, 1 plus tangent times tangent. What do I replace all my A's with? What does it appear that A is equivalent to? 2 pi. So wherever I see an A, I'm going to put a 2 pi. What is the B equivalent to? X. So I'll replace my B's with X's. Well, think about the unit circle. Where is 2 pi on the unit circle? It's at the right. Same place 0 is, right? And what would be the coordinates there on the unit circle? 1, 0? Cosine, sine. So what's the cosine of pi? Do you agree tangent is the same as sine over cosine? What's the sine of 2 pi? Sine of 2 pi is 0 over cosine. So 0 over 1, what's the tangent of 2 pi? 0. So wherever I see that tangent of 2 pi, I'm going to put a 0. And I have this. So that makes this a negative tangent x over 1 plus 0, which is negative tangent x over 1, or negative tangent x. And now we should match what we had. Okay, after 37, somebody had asked me 41. 41, we'll apply our rule. Sine is sine A cosine B, same thing. Then it would be cosine A sine of B. Does that look right for the numerator? And what are these both divided by? Cosine A, cosine B. Cosine A, cosine B. Some things might cancel. And here I'm left with sine over cosine, which is tangent. And here I'm left with sine over cosine, which is tangent, but this one's a B, right? Now they match. This is number 23. It's a tangent, and it has a minus, so I need to find the rule for this one. I believe it's tangent A, same sign, times minus tangent B, over 1 plus tangent A times tangent B. So let me just fill these in. Tangent minus tangent. I don't like that. Fix it up a little bit. Over 1 plus tangent times tangent. Now, wherever I see an A is 4 pi over 3. So I put in 4 pi over 3. 4 pi over 3. The B is pi over 4, so I put in a pi over 4. Now we're going to figure out what these values are. Tangent of pi over 4 is pretty easy. It's 1. So wherever I see the tangent of pi over 4, I put a 1. That's 1 on top and 1 on bottom. Now, I need to figure out the tangent of 4 pi over 3, correct? Where is 4 pi over 3? Is it bigger or smaller than 1 pi? How much bigger than 1 pi? 1/3, or pi over 3 is my reference angle. So I look up the tangent of pi over 3. What is the tangent of the reference angle? Tangent of pi over 3 is radical 3, isn't it? Isn't it?
Yes.
And in this quadrant, it's negative, negative, cosine, sine. Tangent is sine over cosine. What's a negative over negative? So I leave it as positive. So what do I have? I have radical 3 minus 1 over 1 plus radical 3. Looking at the previous answers, I'm going to assume they might leave it like this. The only thing we might do is rationalize it.